Okay. So gonna go over first of all, kick off any project questions, and then we're gonna review the scavenger hunt. Then I want to show in LeetCode, there's a couple like nice like study plans for really like make sure you understand pandas and like how to apply it, like even beyond this class. So we're gonna go over that. I'm gonna do a quick review on version control and then how to showcase or embed notebooks. And then we're gonna do some pandas review and then like continue on to like some new things there as well.
Okay.
Any questions on the project?
I don't think so. I am kind of just gathering what I want to like do it on. I'm just overwhelmed by choice, and I think that's the hardest part is figuring out what data set to use. But I think you laid out just like the order of steps to do, so I think that helps me get a better grasp on what all I need to complete, and I think I'm going to use Jupyter notebooks to build it. So Anaconda seems to be down right now. I don't know, but
oh, really? Like the cloud?
Well, I tried to open the cloud and then try to open notebooks, and it keeps giving a 503 error. Like sometimes it'll open the page, but I don't know, something's weird. So
I hope it works. I'm not gonna mess with it, so it stays.
It might just be me too.
Okay, yeah, that sounds good. Just ping me if there are any questions, any point. Okay, so let's do the scavenger hunt review. Let's see. Okay, so yeah, we'll just go through this. So number one, command to install library using pip, for example, like installing pandas. It's just going to be either here in Jupyter Notebooks or then in terminal you can do pip install. If you have Anaconda set up, you can also do conda install. And when you run it, it's going to say requirement already satisfied if you've already satisfied it or if you've already installed it. And if you have not, then you would install it.
Okay. And you would install that, like you said, terminal where you open up like from your toolbar, right? Like that thing? Okay.
Yep.
And so that's to have it all local on your computer versus doing it in like a browser program. Okay.
Yeah, so the Jupyter Notebooks, like that one is running off of Anaconda.
Okay.
So we can still like install it here, like conda install pandas, and that would install it. That would be the exact same as doing it here.
Okay.
But if you're working on Visual Studio, then you can do like pip install here, and that's just going to, if you don't have any like Python environment activated, then it would just install across everywhere. Like you should like for that, for your current Python version, you will have it installed. But then you can also like, if you use like the environments, like you can use conda environments that we talked about last time, or then you can also use like virtual Python environments, and then you can install them within those, but you would have to activate the environment first. So like if we wanted to activate one of the Anaconda environments, we could do like conda activate, and then I think Python 3.8 probably. Yeah, so now here we can see Python 3.8. So that's our environment right now. And then we could do pip install pandas here.
Okay. And so then is this your text editor then when you're doing this versus something else?
This is the command line.
Okay.
So or terminal. I remember which one's called which. Yeah, so Mac calls it terminal, and then Windows calls it command line. Yeah, but this is the same thing.
Oh, okay.
What was that?
I was gonna say, I feel like right now the Jupyter Notebook is a little more in my wheelhouse, so because it's all there, you have to still import it, but like it's kind of there, ready to go for you. But I do want to get a little bit more adept at like installing, an instance like when it needs to be. But I feel like I want to stick to like what's a little bit simpler.
Yeah, I think terminal, it's very intimidating for beginners. Like it has, there's still a lot of things that I don't know how to do, and like it's taken years to like even get comfortable using it. But we'll do also like a version control example within
Okay.
terminal later on, so to get a little more familiar with it as well. But yeah, Jupyter notebooks, super convenient that we can just run it here.
Okay.
So that works. You don't have to know how to do anything else. I
Okay.
don't just want to. Oh wait, okay, go away. But yeah, pip install pandas or whatever else library, SkyPy, NumPy, whatever it is, and then of course we can import it with import pandas as PD, or he can import it just as pandas. Doesn't you can call that alias can be whatever.
Okay.
Okay, built-in function define a length of a list. That is len. So we have our list here, x equals list 1, 2, 3, and then we can do list len x, and that is going to give us length of 3. Commonly used library if we're working with arrays and numerical data. NumPy is really good for that because it can help you do a little more with the variable. So like if we do an array here, so numpy.array, and it's just going to create an array of this, and then we can do like my array equals my array plus 2, and it's just going to like add 2 to each one of these.
Okay.
So it has like a little, the way it treats your arrays and lists is different. Function to read a CSV file into a data frame. So that is, of course, pandas, like we've been seeing throughout or libraries pandas, and then we do pd.read CSV, and then we can assign it to a data frame. That one we already imported. So yeah, and then we can see our data frame. Library to create and manipulate Excel files. We have not talked about this, so this was definitely something that can go and find. So there's one that's called Open Pi Excel, and you can basically just like, let's just say every month you get an Excel file from your boss, and they say like, hey, like I want you to clean XYZ, and this needs to be added or whatever. You could write a Python script to do like that cleaning or like the workflow that happens. So with the OpenPy Excel, creating a new workbook, creating a sheet with it, and then we can enter, so worksheet A1, so that's the cell, and we'll put hello world, and then we can do workbook save, and we get hello world, and this will be in, let's see, here. So here we see sheet 1, and we have hello world there. And like if it was, every month you get the same type of workbook, like everything's always in the same spot. Like you could do calculations or you could do cleanup and like automatically, remove extra spaces or like capitalize properly, whatnot, instead of doing it by hand every month. Function to concatenate 2 or more data frames. So here we have a data frame. We'll do data frame 1, and it's just 4 columns, 4 rows. Here's another one. And then we'll create a list with the data frames. So we're going to do like frames, and this can be anything, equals list of df1 and df2. And then we're going to do pd.concat frames. And that's how we would get all them concatenated. Another way, you can just pass in the data frames, but it needs to be a list here. So just making sure to include the brackets here. So this is the same way. Same thing. Command to display the first n rows of data frame. That is, of course, .head. And the default value is 5. So if we didn't put anything here, the same thing. But then we can change it to 8. And we'll get 8 rows. Library for creating visualizations and plots. We have, and these are just examples. Whatever you answered might be different, but we've looked at Seaborn and matplotlib.pyplot. Those are two that we've been playing with for a couple classes. And there is others, Plotly. You can technically use Pandas for visualizations as well. So just two examples. Function to group a data frame by a specific column. So we can do, we'll have our data frame and then data frame df.groupby, group it by country and product description, getting a sum of sales. So very similar to, or the language is very similar to SQL, basically, with a group by. Pass in the column names. Command to replace missing values in data frame with a specific value. So we can do df.fillNA, then passing in like what column, and like which column we want to be replacing things with, and then what we're replacing with. So in postal code, only in that column do we want to replace null values with 0, and then in place is true, which means it modifies the original data frame. And we could also, for the fill NA, we'll do it in place. Yep. Yep. Function to calculate the mean of a column in data frame. So for that one, we can just do df column, so df sales dot mean, and that's going to get a mean for all the values in the column. Alternatively, we can also look at the df.describe, which is going to give us the count, mean, standard deviation, minimum, maximum, and then the percentiles for every numerical column. So for example, we can see sales mean here, 3506, which is the same as here. Library for working with dates and times. That is just date and time, or date time. Import date time, and we can do today equals date time dot date dot today, and that is going to give us 2024, 05, and 13. And there's other things you can do. You can compare, like only look at like past 3 weeks of data, or look at get the timestamp for right now. And yeah, there's a whole lot kind of thing. And then like formatting your date and times. Function to apply a custom function to each element of a data frame or series. So for that one, we can use apply. So here's our simple data frame. And then this was one of the examples that we saw earlier. So we have a function map wind speed that is going to take the wind speed per wind speed miles per hour, and then it's going to return whether or not it's dangerous, high, moderate, or low. And then we'll do df wind speed miles per hour dot apply, and then we pass in this function in here, and it's just going to apply it for every single row or record. And then to get, if we wanted to add a column, we can do df wind speed category equals df wind speed miles per hour dot apply map wind speed, and that is going to add the wind speed category here based on the wind speed miles per hour. So here we didn't have it, and then here we're adding it. So dot apply. Alternatively, we can use dot map and then use a lambda. We can use lambda here as well, but just different ways to showcase it. So df, just a silly little data frame. So function to apply. So we're going to do df.map, and then lambda x, and then x is x times 10. And this is going to multiply every single one of these values by 10. So dot map, passing a lambda. And this one could also be a function like we did over here, like a custom function like this. So you can use them both ways. Command to filter data frame based on a specific condition. Here's a sample data frame. So filtering records and rows, we would do, so assigning filter df, and then we're passing in df age is greater than 30. And that's how we get only the rows that have an age that is greater than 30. df, and then passing in the column. Alternatively, we can do a filter by the index using the dot filter. So filtered rows, df dot filter, and then items. This is going to be like the index number. So index 0, 1, 2, 3. And if we had changed our index to be like based on a name, then we would pass in the names in here. So whatever the index is goes in the items. And this one's going to get us only 1 and 2, index 1 and 2. So it does not include Alice and David. And then this one didn't include, this one only included Charlie and David. Then we can also filter columns with the dot filter. So df dot filter and passing the items. So passing the column name. When you're doing it with the rows, like the index rows, make sure to have the axis equals 0 because the default is 1. So here, this one gets us only name and city and drops the age column. Function to merge 2 data frames based on a common key. So data frame 1, data frame 2. And the key here, we have A, B, C, D. Then we have B, D, E, F. So we can do pd.merge. I'm going to pass in data frame 1, data frame 2. On parameter means like the column that we want to merge it on. Very similar to Python when you do a join and then on, what needs to like match. Then we can specify how. So that is what kind of join you want it to be. We can do inner join. Then we can do outer left right. I added this one here as well. And then suffixes to showcase the, like rename the value column. So value left. And this could be like df1 and df2 to make it even more clear. So this one gets B and D that are in both. And then gives us that. So whatever keys are in both data frames. Since it's an inner join. So yeah, the same thing. Command to sort a data frame by 1 or more columns. So sample data frame. And then we can do df.sort values. And then we just do by, and then whatever the column name is. So this is sorting by the name. We're going to get Alice, Bob, Charlie, David, Alice, Charlie, Bob, David here. We can see the indexes are in different order. And then doing multiple columns, the same things, the dot sort values. And we're going to do by, and then this is going to be a list of column names. So city and age. And the order you put these in here is like how it decides which order to sort them with. And then ascending, first one's going to be ascending, second one's going to be descending. So city, so Chicago, Los Angeles, Miami, New York, and then age is going to be 22, 30, 40, 25. function to save a data frame to a CSV file. We just do df dot to CSV. And that is going to save. See. Here's our sample. And we can open Excel. Here's our data frame. One thing to note that it does print out the index column as well. So be mindful of that. Okay, library for performing statistical analysis. We can use NumPy, import NumPy as NP, generating some random data. And then we can just do np.mean, pass in the data, np.median, pass in the data, np standard deviation, pass in the data. And this just, so what this one does here is like, so numpy.random.rand n. So this is just going to create 100 random numbers, a list of 100 random numbers. And then alternatively, we can also use SciPy. It's something that we did look at one of the classes. So here again, we're just generating 2 random sets, and then we can do a t-test. So stats dot t-test and data1 and data2, and then the return is going to be t-stat p-value. Oops, print this one first. There we go. And command to create pivot table from a data frame. So here's our sample data frame. Then we could do df.pivottable. I'm going to pass in values is sales, index is category, columns is the name, and then the aggregate function sum. And this is going to give us each, the sum of sales for each category for each person. So similar to in Excel, we could create a pivot table like this. And then alternatively, we can also do it with multiple columns, or no, this is multiple functions. So again, sales, index category, columns name, and then aggregate function, we have mean and sum. And this is going to give us, so here's like the sum for each person, and then sum for everyone, and then mean for each person, and then mean for everyone. Function to calculate the correlation between 2 columns in a data frame, sample data frame, and then this is, we have df temperature, so temperature column dot core, CORR, and then passing another column, so df ice cream sales, and then the return is just going to be the correlation coefficient, which is just saying what the correlation between these 2 columns is. And that's it for the scavenger hunt question.
Can you just go over again? I know you touched on this before, but like when to use return, print. I see like sometimes you just do like say df or like whatever the, I don't know, the function you're doing is. Can you tell a little bit about how you would choose what to use?
So in just doing like this, so if you in a sum, so this is almost, I would say this is like Jupyter specific, or like a notebook specific. So if you only have one thing that you want to be like output here on the notebook, you can just call it. So like you don't have to put print or return or whatever. You could, but honestly, with the data frames, when you do print, it doesn't like give you the nice format. And same thing if we could do, so we can do like s equals hello, and then we could do s gives us hello. We can also do print s. So this one says like, oh, this is a string, and then this is going to print the value of the string. And there's really, the thing is, if you have multiple things, so like we do hello, and then we do world, and you wanted to output both of these, you can't do S and L. It's just going to show the last one. If you wanted to do both, you'd have to do print. So that's why I'm saying like the not using anything, just doing this is like kind of like notebook specific, because like the notebook knows like, hey, like you want to do this. But if you're trying to output multiple things, it's only going to get the last one. So then that's when you would have to use print. And then in functions, so if we have function hello, we can do print hello world. And then when we go and call hello, it's going to get us hello world. Alternatively, we can do return hello world, and it's going to do the same thing. Like how you would use print versus return in a function is if you wanted to like be able to assign the output of that. So if we have hello and it returns hello world, and we do h equals hello, and then we do h, so that is now the value of this. Versus if we did print, and then we do h equals hello, it immediately printed it out here. And then this one's, since this didn't return anything, h is nothing. Like nothing has been assigned to h because it didn't return something when the function was called.
Okay.
Is that clear?
Kind of. I think it'll just be looking at more examples and finding that like pattern, I guess. And
yeah, you would like, if you are, print is usually not used in like high level applications, because like what print does, it's prints it out on the like log, the console.
Yeah.
It's not going to like, if you did a print and you had like a mobile app or whatever, it wouldn't be printing it on the UI. It would be printing it on the console, the log somewhere in the back.
Okay.
So usually you want your functions to return something.
Okay.
But this is kind of like, printing is great for debugging. So like if you have a Python code and you can't figure out like what is wrong, you can just put like a bunch of print statements in there. And then you're going to see like when you walk through your code where things are going wrong. But that's going to be printed for you like as a developer on the console. And there are like, technically, if it's like a console application that somebody's using, then you could just use the print. But most of the time, you want a return statement if you wanted to output something.
That's kind of what I gathered, is that print was like log it or label it or whatever, but return was like getting back the output that you wrote the function for. So okay.
Yep, exactly. And then this wouldn't work in like Visual Studio if you're running like a code. It's really mostly notebook specific. I think it would even give you just an error, like if you just had a variable in the code that wasn't doing anything, like it wasn't being assigned to anything, and it wasn't assigning, nothing was being assigned to it, and it wasn't being assigned to anything. I would probably just give you an error. So this is really notebook specific, just to see what the variables are doing. Any other questions on the scavenger hunt? not too much new stuff here. A lot of it we had already seen, and there will be examples. I mean, I include examples here, but examples already in the notebooks that we have gone over. Cool. Okay. Anyone else have any questions on the final project before we move on? Most of you were not here in the beginning. So if you have any project questions, like setting up your environment or not knowing where to find a data set, your Python is giving you an error, let me know. And if you don't have any questions today, you can ping me a message in the Slack. But if you want to like walk through anything or you want to show a very specific issue that you cannot figure out, just ask in class. So you have today, and then you have Wednesday to ask any questions. Okay, I wanted to talked about a little bit LeetCode. And let's see, this is probably too small. So yeah, so LeetCode was one of the websites that I recommended last time for like where to go to kind of, strengthen your knowledge on Python. And there's a couple nice things that are called, what are these called? Your study plans. So there's Introduction to Pandas, and then there's 30 Days of Pandas. So, and this is 15 questions, and then this is 32. And basically, what these are, it's like it won't be interactive, like, it's kind of interactive, but like it's not going to tell you where things are wrong. But basically, it just gives you a problem. And this is often how, like, in technical interviews, problems are represented to you. And you can even see here, like, oh, like, have you seen this question over on interview before? And then you need to preview them to see the companies. But there's hints, and then there's some discussion. But like here, it's like, provide a solution to create a data frame from a 2D list called student data. This 2D list contains IDs and ages of some students. The data frame should have 2 columns, student ID and age, and be in the same order as the original 2D list. Result format is the following example. So input student data, and then output is going to be data frame. And then you just type in your solution here. So this one would pretty much, I think this is just return cpd dot data frame, if I remember correctly. And then we can actually just pass in student data. I think it needs to be data equals student data. And then columns equals student ID and then age. Oops. And is this the right way? Hopefully. Yeah. So, and this is like one liner to do this. There's different ways too, but basically there's like built-in test cases, and it's going to tell you whether or not your code works. And sometimes there's like hidden test cases. So when you go and submit it, it's going to tell you whether or not it's like accepted. Sometimes your test cases may run, but then there's like hidden test cases that you didn't consider, and then it would say like, oh, it failed or whatever. And it also will tell you like where you rank speed-wise. Yeah, but definitely check this out to continue learning Python and Pandas. And I'll make sure to link these. They're linked on a notebook, but then, or maybe they're not. But yeah, I'll link them either in Slack or wherever. Oh yeah, 30 Days of Pandas. So these are a little more. So we have data filtering, string methods, strengthen. So these are, and it also tells you like the difficulty of these. Some of these are locked if you don't have premium. Data manipulation, statistics, data aggregation, data integration. Yeah. What did this one have? Yeah, this one has data structures, data inspection, data selecting, data cleaning, table reshaping, and advanced techniques. Yeah. So definitely check those out if you're interested. And then we are going to, okay, we'll do a quick little version control review to make it a little less scary. Okay, so using the terminal, command line, whatever it is on Mac, it's terminal. I think it's, yeah, it's CMD command line on Windows. Alternatively, you can use like warp that I mentioned in the very beginning, I think the first class. It's just a little more intuitive. I think it makes it a little less scary because it gives you, it gives you suggestions. We could do ls, and then you can also like click in here. So it kind of has like an UI, so that's nice. But I think this one, you can make that bigger. Okay. Okay, that's fine. So what we're going to do is we're going to do cd hotel booking. So to initialize a repository, we get, so we're going to navigate to the project folder. So we did cd, and then this was the path to the files, and then this is the directory of my project. And there's nothing else except a CSV file right here. But pretend there's a bunch of important files or whatnot. Okay, go away. Yeah, this is better. Okay. And then what we're going to do is to initialize a Git repository, it's literally just git init. So git init. And that means we initialize an empty Git repository. And then to add add all the files. So Git, what we need to do is like, in order for you to commit or state or like commit your files, you need to either add them or like stage them. Adding and staging is the same depending on where you're using it. But like on the command line, it's just git add and then dot. That means like everything in this directory, like stage them, like stage these changes, we want to add them. If you didn't want to add all the files, for example, let's just say you have a credentials file that you don't want to commit because you don't want it to, because you're planning to publish it to GitHub, but you don't want your password to be on there, then you would do like specific, let's just say like there's a directory like files or whatever. So you would just like put the specific path. And same thing we can do, I think this one, hotel, or like we can just do hotel bookings to add like the files, git add hotel bookings. But I'm going to do, and this doesn't matter, since there's only one file, this one, there's no difference, but we'll do git add, and then it added everything in the directory into our staging change, like stage changes. And then we can do git commit m, and then usually when you first do it, initial commit. And we can look git log, and that's going to show us, this is our commit ID. It's going to show us what branch we're on, and then the commit message, like the latest commit message. If there was like more, like if there were a bunch of other, you could see them. And commit IDs is like how you can rebase or like revert back, revert the commit. But yeah, so git commit main is the branch. That's your commit message. This is the like beginning of the ID. It's going to tell you like one file changed, this many insertions, create mode, whatnot. So then if we want to add this in our GitHub, so right now you have local version control. So this is not published anywhere, but you can track your version control. So the version control file is in your directory, but you want to publish this so you can work with your coworkers or you can showcase your creations or whatnot. We're going to put it to GitHub, and that one, so we'll do github.com. And again, this is very tiny. Let's see. So log into GitHub. I'm already logged in. Top repositories, we're going to hit new, create a new repository, and then repository name, we'll just do hotel test. And then public, if you want anyone to be able to see whatever is in this files, the public, we can do private. And these are optional. You can add a README file if you want to. You can add git ignore, which anything that you put in your git ignore is Git is going to ignore. So for example, you could put like Git, like you would put credentials.json or like credentials directory name, and then it would not track the changes to those and it would not be included in the commits. So create a repository, and then we're going to get the URL of the repository. And this also, it tells you like how to push a existing whatever. So these directions are like everywhere. So, but here's even more simplified. So we did log into GitHub, click new, put a repository name, and then choose visibility. We're going to get the URL. We're going to go back to command line. And then here we're going to do git remote add origin and put that URL that we just got. And then hit enter. And now we've put this as kind of like our destination. And then we have to do, in order to get it, so we go back here. Nothing is still here. Reload. So there's no code here yet. We're going to do git push u origin and the main. Origin is going to be like the URL, and the main is going to be the branch. So if you have like multiple branches, we don't have to get into that right now, but you can have multiple branches to look kind of like track. Let's just say like you and your coworker are both working on this project, but you're working like different features. You could have branches based on the features. So git push u origin main. This is going to say, okay, pushing to here, branch main set up to track origin/main. And now we come here, I'm going to do reload. And then now we have this file here, which was just a CSV file. And you can look at it here. So that is how you do it in command line or terminal. Any questions on this? And now we'll take a look, a little less intimidating way of doing this. So from Visual Studio, and yeah, perfect, okay, maybe too much. This is like one of the data cleaning example we did at one point. So in Visual Studio, you have your project folder pulled up. We're going to click this. This is source control. I was trying to figure out how to describe this. I honestly couldn't, like, because I know what that's supposed to be, but for someone who doesn't know what that's supposed to be, I don't know if it makes sense. But yeah, it's this one like showcases the branching of your version control. So this is like the main line, and then you can take a branch. But yeah, I don't know how to explain this, but yeah. Version control, 3 little circles that are almost connected. But yeah, source control, we're gonna do initialize repository. And that one basically did like initialize it for you. And then here changes, you want to click the plus to stage all changes. So this is same thing as doing get add dot. It would add everything in the directory to be committed. Alternatively, if you only wanted certain files, you can like handpick them. So like we'll just do this one and then this one. And then now only these 2 are going to be committed. And if, let's just say we always wanted to ignore these ones, we could do right click it and then do add to get ignore, which is going to create the dot get ignore file for you. And you want to commit that one because we want to track what we're ignoring. And the reason it's dot is because it's like a hidden file. So like if you were to go to this directory in just like your file explorer, you wouldn't see it unless you revealed the hidden files. But that's what dot means. So yeah, we want to commit these 3 files. And here we have message. We'll do initial commit. We're going to hit commit. Now then it went away. You're committed. And then here is publish to GitHub, the little cloud. And if you're not logged in, it's going to ask you to log into GitHub. It's going to pop up a browser and for you to log into GitHub. And then again, you can do private repository or public repository. So we do public or private, and then we can go look at all my repositories. So here's data cleaning. And now we have data cleaning here and the CSV file and get ignore. So we did here, click on the source control, initialize repository, state changes, /add files, clicking the plus, enter initial commit to message field, and then click commit, click publish to GitHub, and then we'll ask you to sign in. Any questions on this? It's very, very good practice to use version control, and your future you will thank you when you use it because it's easier to keep track of what you're doing. And even if you weren't doing to like track what your changes, you can showcase it to other people on GitHub, or that's like the easiest way to like collaborate and make sure that you're not overriding each other's changes. Okay, we'll do a 10-minute break right now. And then we're going to talk about how to showcase and embed notebooks to show to potential employers or other people or your boss. So be back by 7:10 Central Time. Okay. So let's see how we can showcase our notebooks. And if you have a notebook on your GitHub, it's actually already like it shows it for you here. I don't think you can't run it, but it just shows you. So this is like the sample project that we walked through. So if you just open this file on GitHub, it shows the whole thing with the visualizations and everything. So you could make a dashboard in Jupyter Notebooks and just put these visualizations here. It won't be interactive though, I don't think. Or maybe some of them will be. I've not tested that out. But alternatively, again, if you're using version control, you already have a link that you could send to someone as long as it's a public repository. Alternatively, we can embed it within HTML using NB Viewer. And this is not, you don't have to like import it or anything like that. All you have to do is like, the URL will be nbviewer.jupyter.org/GitHub. And then rest of this is going to be like this part where so you username, your GitHub username, repository name, that's going to be blob, and then this is your branch main, and then your notebook name dot apynb. So let's see, I think so just having a plain HTML file, adding an iframe here with the link, then viewer. And then if we go and look at this, let's see. We'll have it here. So this is the iframe that gets put in here, the NB viewer. And a very aesthetic title that I've added here. Jupyter NB viewer. And this is like, you can't run it, but again, it'll show you all the outputs. So if you have a portfolio website, you have a personal website, you have a portfolio, you can literally just embed a GitHub file, like the notebook file here, and then you could show it to anyone. But it does need to be public, like your repository needs to be public in order for this to work. And does this let? Okay, so you can actually navigate to like the directory. So we were looking at the example, so they can also go look at this one. So that's another thing to just be mindful of. If you're embedding a file, a notebook file, using the GitHub links, it will, whoever is looking at here will have access to the rest of the files in that directory. So just to be mindful of that. You would, if it's something that's like you're publicly using on your portfolio or whatever, I would probably just make a repository with just that one file that you want to showcase. Then here's some FAQ. Oops. And here you can get the raw code to the notebook. And what is this? Camel. And then view it on GitHub. So this link will take you, oh, refuse to connect. Well, it should take you to the GitHub. And then they can also download the notebook. And there's probably ways to not have these, probably settings for the ME viewer to prevent downloads and once you get help or whatnot. But that's what I'm going to do. Questions on this? On this or showcasing them on GitHub? No questions? Okay. Okay, we're gonna go, gonna do a little bit of review of Pandas, a little more, and then go over some new things for Pandas using Anaconda Cloud's notebooks. So if you want to follow along, navigate to anaconda.cloud and then go to notebooks. Hopefully this works now. Melina was saying it wasn't working earlier. So anaconda.cloud and then notebooks. And then from here, we're going to do Anaconda Learning, data analysis, introduction to Pandas for data analysis. And starting with the Pandas series 1. I have these already opened over here. So, making sure everyone can see this. So some of this is a little bit of a review, and then later on we're going to get into some new stuff. Yeah, we know a little bit about Pandas already. Can create series from Python collections, doing math, describing our data, filtering series, operating a series of strings, using filtering series attributes and methods. Pandas is the leading data analysis library for Python, built for acquiring, cleaning, organizing, and analyzing data. Series and data frames. We've been playing with data frames a lot. We're going to see a little bit more series with these notebooks. Pandas is fast, faster than base Python, enables accomplishing more with less code. So yeah, Pandas series part 1. So creating series objects, assigning series, doing math, describing series. Doing the usual import pandas as PD, and we can create pd.series from the list of 7, 8, 9, assigning series to variables. So like series is just, think of it like just one column in a data frame. And that's what I'd like. We have our index and then we have a series. It's going to tell you what D type it is. So integers, results. We can do true, false, integers, booleans, strings. So very simple, just like a column. We can do range for the series. So this is kind of like if you wanted to, I think we've seen an example of this, like when we wanted to just add a new column with values that we just set, we would create the series and then we would make the data frame column like df sales equal to pd.series. So yeah, this is just different ways that you can generate data. So range here means that it's going to do from -3 to 2. Again, so inclusive and then exclusive. Same way as when we're slicing data, slicing strings, slicing arrays. So it created from -3 to 2. So numbers, oops, this one. So it's adding 1 to each one of them. follows Pandas times 2 plus 5. Okay, negative 4 plus 5. No, negative. Yeah. But yeah, you can just do, we looked at the operators before. You can use whatever. Yeah, I'm gonna like this stuff, I'm just gonna go like pretty fast, but if you have a question, just stop me. Prices. Yeah, so just different ways to, like when you have the series, you can do any operation on it. And this is just different examples of how to do it. Then we can do dot index. So we have our S equals series. Dot index is going to tell us the index, like info about the index. So we have 0, 1, 2, 3, 4, 5. Starts at 0, stops at 6. And again, this is like exclusive. Step by 1. Zero place integer indexes. And we can also use strings and dates as index values, as we've seen before, like assigning the index to a name or the username or a date. So if you're like looking at time series, you would use the date as the index. Dtype, same thing as on data columns, like data frame dtype is going to give for whatever for all the columns, and then this one just on the series. Returns only the values, dot values. Shape is going to give us the number of them. Similar to, and since it's just one, because it's only one column, it's going to give us only one. Instead of when we do shape on the data frame, it will give us, 6, 3, 6, 10, or whatever. Value counts going to give us the frequency. So here we have 2 8s, 3 9s, and 1 7. S.value counts, 3 9s, 2 8s, and 1 7. Mode is the most frequent occurring value, median, middle, average, standard deviation, dot min. So same way we can do how we were doing in Pandas, like data frames. Same thing. Not a whole lot of new stuff here. Describe, same thing as in Pandas, just gets it that for that one column. And here's some exercises. I'll leave those for you guys to look at. Oops. Any questions on this? Really nothing new. We're just looking at a singular column instead of the whole data frame. We talk about comparison operators, Boolean indexing to filter data. We can import Pandas. We can do a range here. So this is, let's see, what does this one? This is just a, okay, so range and then range 0. So like we saw previously for a series, if we use this to fill a series, it's going to be like a list of them, but you can still access a range with the index. So at index 0, we have -2 because that's the first value in the range. And same thing. So this one would have 5 values. 5. Nope. Yeah. So 5 values, but index 4 is the largest. So 0, 1, 2, 3, 4. And again, exclusive. Inclusive, exclusive. Why that is, who knows? Same thing, what we did earlier, we just passed in the range here, so we didn't assign it to a value yet. Corresponding index for the first element is true and rest are false. So filter Boolean masking, calling this -1. And yeah, sure. If all Booleans true, return original series. Okay. So this will basically just like, you can determine which values you want to get from the series. Not sure exactly how this will be used. Like, and if they're all false, then nothing is going to be returned from. But yeah, Boolean indexing. So you're passing in whether or not you want to see them. So yeah, first and third, or index 0 and index 2. But this one does not modify the original series. Comparison operators. So checking whether or not SER equals 1. So it's going to return a true for any value that does equal 1. So at index 3, we have 1. So only that one equals 1. Then mask equals SER equals 2. So this is going to be, this one's going to return a Boolean. And then this is going to, so basically like, if we look at mask alone, it's going to give us like the Boolean indexing that we were here before. So this is how you can create your Boolean index with the condition. So basically every single other one is going to be false, and then the only thing that does satisfy this condition is going to be true. And then you can pass it in the same way we did before. We can also put it in inside here instead of assigning it to a variable. So these are the same things, just removing the variable. Is negative. Yep, same thing. So this is equal. Then we're looking at less than 0. So only those ones. Same thing, just different condition. Same thing. And yeah, the substitute copies of data, we're not doing anything to the original series. Same thing, we're doing a modulo here. So this one's gonna get us odd numbers, I think. Yeah. So modulo here. So when value divided by 2, the remainder equals 1. So meaning it's an odd value. Passing it in gives us only the odd values. Okay, so doing a new series from 1 to 13 or 1 to 12. And here we're doing our OR, and this one can just be, can this be OR actually? Let's see, numbers. I don't think so. Nope, we cannot use that. Okay. So Boolean series, we cannot use and OR that we use normally. So using and then the pipe is OR operators needs to be used when we're doing the Boolean series. So we would want all the ones that are 2 or all the ones that are 5. So we get 2 and 5. Sending and nothing, no value is both of these because it's not possible to satisfy both of these conditions. So we get a empty series. So this one is just, if we don't want to have the parentheses here, you can assign this condition to a value, a variable first. So is even equals numbers modulo 2 equals 0, is divisible by 3, and then that way we can just do is even and is divisible by 3, passing it in. And then and just both of them need to be, so it's divisible by 2 and divisible by 5, then it's the only one. Or you will get all even numbers and then all, and then we have 5 here. Yeah. And this is just showcasing all different ones. And then what do we have? The dot lock. So again, we're looking at numbers. Numbers dot lock even equals 200. So every even number gets assigned to 200. So if we wanted to just change the values here. Let's see. The same thing we can do. Numbers dot lock is even. So this is going to give us the subset of even values. We're going to assign it to numbers dot lock is even times 2, making it just dynamic. So it's going to give us all the even numbers are going to be multiplied by 2. Some further reading, and there's some exercises down here. Any questions on this? And again, this is mostly just, we're just going over like everything that is possible with the series. Okay, so let's look at strings series. So we just have our column with different strings, some fruits, store values, same thing as in data frames, PD, that's for values, sorting these, ascending false, nothing new here. And this one, we can use the in place true, how we've seen that before with data frames, or we can just assign it. And then we're going to ignore index. Capitalize and capitalize. So fruits, so our column, string dot capitalize, and it's not going to, oh yeah, capitalize is the first one. So I think this is same as sentence case potentially. If we were to do, let's do apple pie here. No, it's just capitalize is the very first one. Yeah, I think sentence is the one that does, no, title. Is it title? Yeah, title will do title case. But again, it does not, since we're not doing it in place or we're not assigning, it's not modifying the original. Here we are doing it. So dot contains is going to give us a Boolean series. What were we talking about earlier? And remember to use dot string, like dot, whatever the data type is, to be able to look at it. And we can filter it. So we have apple pie and then pineapple, which maybe we shouldn't do apple pie because it doesn't make sense anymore. There you go, apple, pineapple. Dot count to count the substring occurrences. So dot count A. In the first one, we have 1A. Second one, what's our second one? It's banana. We have 3 A's. And so on. Counting berry. We have blueberry, cranberry, raspberry. So 1, 1, and 1. We can, okay, so getting the vowels. And this one could be, yeah, here. Jumping ahead of myself. But yeah, counting A, E, I, O, U. And I was going to say regular expressions. So just passing in this is going to give us the same results. Checking, and here we can pass in so filtering that the vowel count is greater than 2. Get the fruits. Banana, blueberry, orange, pineapple. You could also do dot start with. So if it's L, we have 2 here, which are lemon and lime. And again, filtering them. Ends with berry. Dot len is going to get us the length. Dot lower, we've seen this before. Just going to lowercase all of them. And alternatively, we can do upper, which is over here. Replace, dot replace. This one's gonna object, not doing anything to these. What's up here? Times 2. Yeah. It just, so here we have string values of like prices. We're getting rid of the euro sign. However, if we do an operation here to multiply it, it just multiplies the string. So we'll get 599 and 599. So dot as type, same thing as before, float, and then it will get us. Alternatively do upper. This is in a strange spot. Yeah. Any questions so far? This is mostly just review. But if you have a question, let me know. We've seen almost all of these in different, like whether it's on a data frame or when dealing with strings, like dot replace, dot upper, dealing with strings and such. Okay. So data frames, we're familiar with these. Let's see if there's anything we haven't learned yet. Our simple data frame, oh no, this is just a dictionary. So dictionary, and then we can pass in a dictionary to a data frame to get our data frame. Item, quantity, price, item, quantity, price. And alternatively, instead of having item, quantity, price, we can just do item and then pass in the values. So this is kind of like, this is our column name, and then these are the rows to it. Passing it into a data frame, creating one from list of list. So think of this kind of like matrix of the values. So first column, second column, third column, first row, second row, third row. But with this one, we need to do column names and then row names. I think like this is the index now. Index is the row names, but we don't have to do this. If we just do it this way, we just get our regular 0, 1, 2, 3, 0, 1, 2 index here. This can be anything. So different ways to create a data frame from scratch, which probably not a super common occurrence. As an analyst, you're most likely usually going to be importing it from a file, CSV, URL, database, instead of manually creating your data, because that's not very dynamic. And we can do creating an empty data frame, and then here we're using series. So do you have item? Item is the column, PD series, passing in a list of these, and it's going to become our column. Alternatively, we can just do a list, and then this one's a set. Either one works. It's going to get assigned in the order that it's written in here. Same thing. This is nothing new. Dot shape returns rows and columns. Dot shape 0 returns the rows. Shape 1 is columns. len is going to give us the number of rows. And then size is going to give us rows times columns, like number of rows and columns. So 3 times 5. Adding new columns. We've seen this before. We're just going to do df and then whatever we want to name the column. And for example, here, we're going to do quantity times price. And then we added subtotal here. So this is example of like for your final project, if you wanted to do some feature engineering, adding here we're doing a subtotal, so the calculation, or then you can do like the buckets that we saw with the scavenger hunt in my answer example was like doing the wind speed and categorizing them. Setting index, overriding the default index. So default index is always 1, 2, 3, or 0, 1, 2, 3, so on. And then instead we can do set index, select the column in place. So now the item name is going to be the index. Dot index goes the values. You can also do dot string dot str dot lower. Just going to put all lowercase. Get the column names, df columns, df dot columns. We can create a new column with just like this. If you wanted to assign it to just single value, which is not a super common occurrence, I think. But you can do that. Total cost, column does not exist, but this bracket syntax creates it. If total cost equals subtotal plus subtotal times tax. So this is tax here is tax percentage. So we're creating total cost that is just going to include 7% of this with the subtotal. Dot price gets us the price column. Same thing as accessing it this way or calling it this way. You can also do just dot price. D types, we've seen this before. dot info gives us the number of non-null values, dtypes, in this describe, and this one calling a specific column gets it for the specific column, or then get it for the full data frame. We've seen this before. A column in a data frame is a series. So df.quantity, it's a series. So yeah, value counts. So what we were looking at earlier, calling, since the column is a series, whatever we were looking for series, all the functions, we can do them here too, or call it the same way. Dot quantity, df.quantity.value counts, df.mean. This one gets it for each one of the columns. Mean, standard deviation for each one of them. And yeah, if I think like you can use dot quantity, like I've personally learned to just use the brackets. And that one, like if you have symbols, characters, spaces, this is not going to work. So that kind of like using the brackets just for consistency, I think makes it a little easier to understand. So here's like a example. So we added a shape column here. So when we do dot shape, that is a built-in function. So you can no longer call it with dot shape like we were to call dot price. So that's why I think this is just better practice. Because it can get confusing if you're just using, like if you're using both in your notebook. Consistency is the key. So I would just like pick one, stick with it. Most likely this, because if you have a space in there, you can't use this. And also, if it's a already in use function name, you can't use it. You can rename. So this one just, if we pass in a dictionary, so shape, rename to item shape, total cost, the total, and in place, we're renaming. Shape becomes item shape, total cost becomes total dot rename. Pretty sure we've looked at that before. Here's some exercises for you guys to do later. And then let's see, data frames. Continued. Importing reading a CSV dot read underscore CSV. We've used this a lot. And this one is using a URL, but it could also be obviously a local file. Can get, oh yeah, autocomplete. So this one, the tab character. So here, I think I showed this at one point. This not. There we go. So when you do dot and then hit tab, it's going to give you options. Do count. I want to do count. Yeah. And this thing, using the, I think we looked at it quickly, using the question mark at the end. It's going to give you like what the function does, what the parameters are, what the return type is, and examples, how to use it. Tail, same as head, but looks at the last records. Yeah, so if you wanted to look at only a specific subset of columns, we can do the column names, pass it in here. That way we only look at those ones. Alternatively, just do the score brackets here. We looked at mean. So for these two columns, get mean. And this is for the columns. This is for each row. So getting mean between these two columns. Row-wise. So this is adding a new column. I've seen before, average mileage. Value counts, looked at it before. Boolean series. So MPG, so our data frame, dot manufacturer, which is our one of the columns. How many of the rows have value Audi? And then by getting a sum, we're going to get the total number of rows that the manufacturer is Audi. Then we can get same thing, how many of the cylinders are 4, and then get the mean of them. What proportion? Yeah, so getting, because this one's going to, again, remember it's returning as a Boolean series. So it's going to return true, false, whatever. Wherever the cylinders are 4, it's going to return true. Otherwise, it's going to return false. And then it's just going to get a mean of how many of them are true. So 0.30 or 0.346, whatever. Use the filter, 5 cylinders. Same way we used before. Same thing that was saw earlier, Boolean series. And here we need to use the pipe. Class is midsize. Display. I think that's what it is. Maybe. My display is less than 2. And again, we can't use and. We need to use this symbol. Creating a new data frame of just one column. And if we remember, whenever we are assigning, so we have our original data frame, then we're going to do new data frame equals origin data frame or original data frame. So the address, the memory address of this variable, new data frame, new DF, is just going to point to the same memory address as the original data frame. So when we go original data frame, adding a Y column, that is going to be value of X times 100. The new data frame, that variable also points to the same memory address where the variable is. So we can't, if we wanted to just do, like, we need to do the copy. So new df equals original df.copy for them that to actually copy over the value, like the variable or the object, instead of just changing where it's pointing to. Questions on that? I hope I'm explaining that clearly enough. We did look at it earlier, but just a reminder. because very easy mistake to make. So here, when we create the copy, new df equals original df.copy. And then we add a column to original df. Now the new df is just whatever the original df was when we created the copy. Sorting, seen this. Sort values by column name, ascending, ignoring index, and then we're just getting the head of this. Sorting values by multiple columns. Part of, we did an example in the scavenger hunt answers. And then if we wanted it to be, again, this one doesn't change it in there. We need to do in place true in order to modify the original data frame. Any questions on this? And so far, just review on data frames. Let's do, what's in here? Okay, we'll do this and then we'll take a 10-minute break. And this one does not, this still seems to be very much review. So we're gonna do missing values and removing rows. Pandas, here's a simple data frame. .info, we see the count of non-null values. So we have 5 entries. Every single one has a non-null value except the serving size, which is true. We have NaN and then we have none. NaN, none. And NaN means not a number. I did not know that. Learn something every day. So whenever we do any calculations, we're ignoring any of the null values, but you're not going to get an error for it. Value counts also ignores them. So drop NA. So if we do dot value counts and then pass in drop NA, it's going to count the missing values, which we can do the is NA. So dot pat is NA. We've seen this before. Doing it on the whole data frame. And so here, getting the number dot is NA dot sum. Normal values 2, 3, 2, 2, 5. Proportion of the null values. And then number of nulls by row. We've looked at these before. Proportion of nulls by row. Yeah, handling missing values. No one right answer for all cases. Sometimes you want to fill them in, like we did one of the examples, filling in the zip codes, filling in the states, filling values with median, mean, or dropping the entire row. Sometimes it's appropriate. So sometimes you just want to keep them. So drop NA. This one is getting rid of every row that has a null value. So this one will get rid of all of them because every single one of them had a null value. Any columns, when we do axis equals 1, all the columns that had null values dropped. Well, we have now modified the original. Then we can drop the column. So discount, null value. df drop, dot drop, columns discount in place, getting rid of that column. And this next spam. So this one, we're getting rid of the spam column. So dropping it by the index. So in this data frame, the item name is the index instead of using numerical 0, 1, 2. So dot drop index equals spam in place true. So drop all rows or the row at the index equals spam. Alternatively, we can also do the df bracket df.index is not spam, and that would get us all the records that the index is not spam. Any questions on this? Nothing new. Except, well, not really, but just a different way of that. Okay, we'll do a 10-minute break and then we'll tackle rest of these. We'll get into something a little more advanced stuff. So be back by 8. We'll do like 8. Yeah, 8. We'll do 8:15 since we're already over that. Couple of minutes. Okay. Continuing on. To the same sample, the data frame. Yeah, fill nulls with zeros, fill NA. Then using dot LOC, dot lock, row indexing and column indexing, start row, end row, column start, column end. So doing this one, so column to start and end, and this is empty, so returns all rows and columns. Here we can do dot LOC, club soda, to banana. So club soda to banana gets these 3 rows. This is row nothing here. It gets all the columns. Uses the indexing. df index equals apple. It's going to give us only the apple. Serving size is 3. So this can be applied like index for the indexes and then serving size. So this is same if we had the brackets here. So using the column. We can also do multiple. So dot LOC, index equals apple, and then from serving size to fat columns. Serving size to fat. So we're dropping the last 2 ones. So this one allows you to look a subset of cells. All rows, only calories, dot LOC, have a colon here, and then calories, just the columns. Calories to price. Calories to price. Whole rows. It's really funny because this one's saying like the warnings, but it's not actually giving us the warnings. .lc, which can be like, again, like this one's talking about warnings. It's a potential that like there were some things that like Python would warn about, but then with the newer version of Python, they no longer warn about that, depending on whenever these notebooks were created. Here, dot lock, df calories is null, calories 0. This is just a longer way of filling the null values in a specific column with 0. I'll probably do the way we learned before. But setting is null. This is filling in with mean. Price is mean, so these 2. This one is adding. So spam, basically we had 0, 0, none. So we are like refilling the information here. .lc df.index equals spam. So only looking at the row spam. From calories to price columns, we're going to be inputting calories, fat, sodium, and price. And then we can see these got filled in with this. And it just overrode all of them. Like even the price we had just filled in with mean. but we set it to this one. So totally overriding. Creating a new column, DF discount. And we're assigning to 0. So if we wanted to do something more with that, we can, which this might be somewhere in here, maybe. No, totally different data set. Is it? Yeah. Anyways. This is kind of new stuff, but we've gone over similar. And I feel like the other way of doing this makes a little more sense. But yeah, and then I think this is going to complain. So let's look at the aggregating. There's some new stuff here. So looking at, what do we have? Tips. Okay. So dot crosstab. Crosstab computes a simple cross tabulation of 2 or more factors, computes a frequency table of factors. Example, counting up how many tables ate lunch or dinner for each day, counting the number of smoking tables broken out by gender. So let's see, we're getting all the different days. DF day, DF dot day. So column day, get unique. Gonna give us the unique values, different times. To count lunch, Thursday lunch, we need to compose this compound indexing operation. So df bracket df dot day equals Thursday. So rows where the day is Thursday and time is lunch. And when we do dot shape, so if you remember how we're looking at, this is going to return a series. Or no, it's going to return the data frame and then getting a dot shape. So when we do just shape, it's going to give us rows and columns. So index 0 is the rows. So there are 61 rows that were Thursday lunch. Then 1 row that had Thursday dinner. Then we can do value counts. Let's just say there was another like lunch, dinner, let's say there was breakfast. This would give for all of them. df bracket df dot day equals Thursday dot time, then value counts. So instead of doing that, we can do dot crosstab. So we're going to do index equals df dot day, columns df dot time, and this is like maybe a little time. I feel like maybe like it's meal time. A little confusing maybe. Meal time. So meal time, dinner, lunch, and then day. Friday, Saturday, Sunday. And it's going to give us the counts for all of them. Frequency count. pd.crosstab index. So day is going to become our index. Columns is going to be time. If we do margins equals true, it's going to show the totals at the bottom and at the right. This is similar to like pivot table, but just doing this. Normalize equals true, shows percentages instead of raw counts. And then dot round to is going to round it to 2 decimal places. pd.crosstab, index equals day, columns equals time, margins true, giving all of the totals. Normalizing gives us percentages. Dot round rounds into 2 decimal places. And we can do lists of series instead of just doing one. So here we're doing index equals day, and then columns is time and smoker. So we're gonna get yes and no for dinner. It's like hard to say because there's no borders, but we get yes, no for dinner, yes, no for lunch for each day. So yeah, very similar to Excel's pivot tables where you can just keep adding. So then using pivot tables to do, so crosstab is to use just for like frequency counts, and then that pivot table, like we took a look a little bit earlier, we can do like some calculations, whatever the aggregate functions are. So pd.pivot table, df. Oh no. Did I forget to run one? df. Let's see. What is the problem? Cannot convert male to male, male, female. Are we trying to do that? Let's see what we have. df. Okay. I think, yeah, this one has, let's see. This is a new parameter, Python pivot table numeric only. Set the unstack, set index. We could look at it here, which I never look at. I feel like I recently saw this, but now I don't remember what it is. Let's see. If we were to calculate, or we'll search this thing. Numeric only. Okay. This is what I thought it was. I wasn't sure. So we're going to do include numeric only. And that did not work. Pivot table? Columns. Hold on. Well, we could do just, this is not Python pivot table. We need to use display. Sure, this one. We can ask ChatGPT though. They will know. So let's do an example how to debug with ChatGPT. We can do, let's see, df. So how I would approach this, we're gonna get like a mini set of the data. Have the following data frame. Trying to do a pivot table. I'm getting this error. And then I'll just put in the whole error. Yeah, there we go. Let's see what it will do. Okay. So the numeric only works for dot mean and then dot sum, but it does not work for the pivot table. So we have to pivot table. Oh, this one doesn't have. Okay, I see. So we're missing this thing, which means pivot table values tip. Yeah. Returns a, right, okay, this is meant to be, right. It's, if we don't have the values, this one works, right? Yeah. If we don't have the values, it's going to give us an error. So that is expected, actually. That's right. So we need to have the values in there. And that's what ChatGPT told us. So if you want to calculate the mean for specific columns only, you can specify them in the values. And without doing, if we just do agfunc equals mean, it will do it for all of them. So it knows. So pivot table, df index to column time, values total bill. So we're just doing the numeric average for the total bill. And then if we want multiple columns, we can do the list of them. Again, we're going to get total bill, dinner and lunch. Same thing, tip, dinner and lunch. And then using the agfunc argument to override the default mean function. So agfunc median. So now we're getting a median instead of mean for the pivot table. And then we can also do multiple of them. Agfunc minimum, median, max. So minimum, dinner, lunch, median, dinner, lunch, max, dinner, lunch. Any questions on this? So if you've done some analysis on Excel, like pivot tables and stuff, similar stuff. And this one could be combined with, on the scavenger hunt, talked about a little bit of like the PyXL, whatever that library was called. We could output this into an Excel sheet. Okay. Another aggregations. Group by, we looked at that a little bit. Using the same data set, done the median. So here we're doing the numeric only. So df.mean. So getting the average for all of them. If we didn't do this, it will give us a type error. Getting minimum and maximum, seeing that. Describe gives us all of these. We've seen that. Okay, let's see what we're looking at. So Thursday, we're basically creating like subsets of the rows. So Thursday equals all the rows. That day equals Thursday. Friday equals all the days that equals Friday. And then we can do Thursday total bill mean, Friday total bill mean, Saturday, and so on. And a better way to like print this out would be to create a loop, including like inputting these into an array, looping through them, and then getting, like we could do, let's see, if we put days equals Thursday, Friday, Sat, Sun, and then we can do for D in days, other day in days, print day dot total bill dot mean, and this one should work. Yep. So here's like an example we were talking about earlier, whether you want to do a return or print. And this one I just wanted to print all of them out. And this is another, what I was saying, like, oh, if you have multiple, you want to have multiple outputs. We have multiple outputs in here, but as long as you separate them, like they're in one line and you put a comma in between, it will output them because it's going to create a little tuple out of them. And this one, you don't really have, like, you only have return if it's a function. Like you've done df function, then that returns something. This one, like something that you can call, then you would do return. Group by, seen that before. So grouping by day, total bill and mean. And this one is giving us the same values as here, 17.68. 8. These are just not in, these are alphabetical order, I think, or just in a random order. I think alphabetical. And this is just an object, compound entity that you call these on. So this one, so this, it doesn't print out any results, even though like we can see this outputting, but if you had this in Python code, it would not be outputting anything unless you printed it out. So here, containing multiple tuples of data frames for each possible categorical value. So, not recommended to do this. But for context. Go by day for each. The same thing as earlier. And this one, again, if we don't have the numeric only, it's going to give us a could not convert. So doing will give us for all the numeric values, all the numeric columns. Grouping by more than one column. Again, we'll get that before. And again, numeric only. I think this used to not be required to have this parameter here. And that's why these are giving errors. Group by more than one column. So grouping by day and time. Then list of numeric columns. Oh yeah, so we don't need that if we only do. So instead of doing numeric only, we can specify which columns we do. And that's double bracket after group by day and time, double bracket, total bill and tip, and then you can get the mean. And since we already know these are numeric, we don't need the parameter here. If we want these to be their own, like we want to just like break it up, we do the reset index. So here, this is basic, like daytime is our index here. So Friday, dinner, Friday lunch, Saturday dinner, Sunday dinner, Thursday dinner, lunch. So those are like, this is our index. But here we're breaking it into like not having merged columns. If you like think about, you know, you can merge a column, merge in whatever it's called in Excel. I don't remember. But this one just puts the value in each column. I'll reset the index. And that's like not what reset index does, but it just gives us every single row gets the numeric index. And we're doing numeric only, reset index, okay. Grouping by day, total bill and tip. And we can do the describe. So this is similar to when we can do describe transposed, but doing grouping by time, total bill. So during lunch, getting count, mean, standard deviation. Or we can just choose .ag, mean and standard deviation only. Grouping by day. There's different ways to wrangle this stuff. We're looking at total bill, tip. We want mean and standard deviation. Total bill, mean, standard deviation. Tip, mean, standard deviation. And here with the .t, we transpose it. So the same thing, we flip it. If you've ever in Excel, you paste or like copy paste and you transpose it, it just flips the rows and columns. So day, Friday, Saturday, Sunday, Thursday, total bill, mean, standard deviation, tip, mean, standard deviation. So different forms of group by. So this is a specific example, but instead, can you guys still see it if I zoom out, or is this too small? I'm trying to show the whole thing.
I can see it okay.
Okay. So TF that group by day, mean. So general form, df dot group by your column, oops, and then your aggregate function. Then alternatively, we have group by categorical column, numeric column, aggregate function. Then we have category, numeric column, and again, this one says A because you can have multiple, aggregate function, group by category A, numeric column B, aggregate function, category A, category B, aggregate function, category, aggregate, min, median, max. And lastly, we have by category, numeric A, numeric B, and then ag, min, median, max. So all the different kinds of things. I'm sure there's probably more, potentially. Additional resources, we'll probably tell you. And exercises. Okay, let's see what we have in. Okay, we touched a little bit on these in the scavenger hunt, actually. So we'll do, so string concatenation. We've seen this before. The string plus string plus string. It's just going to put all of them together. Place concatenation. It's just going to make a one big list. The data frames concat is going to put them on top of each other. So just append rows. And we saw an example of this in the scavenger hunt. So pd.concat fruits. So df1, df2. Note that it will preserve the original index for each data frame. So we have 0, 1, 2, 0, 1, 2. So if we wanted to, is that what it does? We can do here, is the reset index inside here? True. Yep. It's on the outside, I think. Is it? Reset index. That's true. Yep. And then yep. No. Reset index. True. Is it this one? Gosh, I don't remember. Anyways, I'll find an example for that. But, and there's probably an example here. 0, 1, 2. And then, so axis 0 is a default argument. So vertical concatenating. So appending rows, axis 0. Ignore index, it does go in here. But, oh, that's what you do with the concat, not reset index. Yeah. So ignore index will reset the index to just continue it on. Alternatively, actually, I think we could call it, we save this into a data frame and then call reset index. That would work too. But this is how you can do it while you concatenate it. If we don't have values, so fruits, we only have one column, which is name. The vegetables, we have name and quantity. So whenever we concatenate this, it will like add the column, but it's going to be no values because it did not exist in the first data frame. But it will not give you an error. And if it didn't share any columns, then it would just pay those for the columns that it didn't, those values, like records didn't have original. And here we are, so axis 1 is appending columns. So we're doing price, quality, price, and presentation, concatenating it with vegetables. with axis equaling 1, and we're going to add these columns in here. And you can concatenate as many as you want. Vegetables, and just continues on. The merge, so merge is join in SQL, but they do also have join. So merge is more flexible. Inner, left, right, outer. We have users. Then we have roles. User ID, name, role ID. And then roles have role ID and role. So if we wanted to merge, see what role does each user have, we'll do users.merge. So an inner join, users.merge, roles. So we're going to do data frame 1 dot merge, data frame 2, left on, right on. And this one was, you can also do the on if it's the same. So in SQL, when you do join on and then you do like alias dot whatever equals alias dot the other column name. So if they're identical, you can do on. If they're not, you do left on and right on. And then how is inner? So we can get here, we have 2 null values and role IDs, so it's only going to return the 4 because it's an inner join. Oh, not that one, right here. So Bob is an admin, Mary is an author, Sally is a reviewer, and Adam is a reviewer. The same thing here, we can do on role ID since it's the same in both of them. And then left join, it will add it there, all the records from the left, all the records from the user's data frame. Same thing as in SQL. And then doing on right, it's going to add this here. But it will not keep these 2. For Jane and Mike. Same thing. I've got outer. Outer join keeps all the records from every data frame. You learned this in SQL. I hope you learned it in SQL. I'm sure you did. So, dot merge. That is how it works. Very similar to join in SQL. All right, last one. Working with files, we look at these, so different ways. So this is going to be review. So reading a URL, pd.read.csv URL, using a URL to access a CSV file. We've done that. And then if we want to set the index column, read URL, customer ID as our index column. And then here, okay, we have a custom function, df download CSV, passing in a URL, passing a file name, like what we want to save it as. So R and requests. So we imported this here. Import requests. That one lets you do like HTTP requests. So R equals requests dot get, passing in the URL. So basically it's going to send a request, like a GET request if you've ever worked with APIs. Probably not if you haven't coded, but We're sending a request to the URL, and then we're going to get back a status code. If status code is 200, that means that's good. And Apple is doing these weird. No, it's not working. Anyways, like 404 is not found. 503 is access or like access denied or whatever. But 200 is a good. So we were able to request that website or that URL. Then we're going to open. So with open, destination file name, so whatever we want to name it. And then I think WB is read, right? And I don't remember what the B stands for. But basically, we're opening it as with like write permissions. Out file, that's the alias of the file. Dot write, and then r.content. So r is the contents of the URL, and in this case, we're expecting it to be, it's all CSV files, so it's just comma delimited data. So outfile.write, r.content, and if it was like a regular website, it wasn't a CSV file, it would put in like the HTML content or like code, and then we're gonna print downloaded destination file successfully. And if we didn't get a 200, it's going to say failed to download. So here we're calling it different CSV files. So that's the URL 2020, 2021, 2022. So calling download CSV, passing the URL. We want to name it as 2020 sales.csv, and the same thing for these years. And this one I think is no longer needed to do this thing. So let's see if this runs. So downloaded 2020 sales.csv successfully. Oh yeah, this one, well, for pip install, you don't need it. But yeah, this one is a terminal command. So first we ran this 3 times. We got the downloaded 2020 successfully. And then this one is going to do ls, which means list all files that end in CSV in the current directory. ls, and that's why it's printing out these. So we can check, and they appeared here as well. Questions on this? And then this is a different way, just looking at sales, and these are wildcards. We don't, but this is how you can get like all of them, but you don't need a terminal command for this. You can also, I mean, it is faster, it's just one line to do it, but you could do it in Python, like loop through all the files and like get all the files that are just CSV or sales.csv. But this is how we got all the names into a list. Programmatically reading multiple files. So sales data. So for file and sales files, so each of the CSV files, we're going to do data frame pd.read CSV file, then sales data append df. So we're creating a data frame for each one of the CSV files, and we're going to append, we're going to put all the data frames into a list, sales data, and then we can do .concat. So sales df equals pd.concat, sales data, ignore index true, and sales df. So this one gives us 2020, 2021, and 2020. All these, like if we were to look at these, I don't know if we can, yeah. So this is 2020, this is 2021, 2022. So we put all of those together with this. And then to CSV, all sales.csv. It's going to save it as a CSV file. Embedding. But again, like I said earlier, it's going to turn the index into one column. So when we save it to CSV, you can do index equals false. And now it saved the second one, or the clean. No, it doesn't have it. See what is here. There's some Excel and clipboard. We won't get into that. Any questions on anything at all? Is Pandas slowly starting to make sense? Hopefully. If not, go leave goat. 30 days of Pandas. You'll be an expert in no time. Everybody good? Any questions? This is such a fun feature that I've done accidentally. I was once taking an exam, like online exam, and I did this, and the balloons came, and I was like, whoa, they should really disable that for professional things. All right, well, if there is no questions, that is all for today. Your final project is due at the end of the week. We only have one more class on Wednesday. If you have any problems or questions with your project, please bring them to class on Wednesday or ping me in Slack, or you can also put it in a group. But that's it for today. I will see everyone on Wednesday. Cool beans.